Now that we're up and running with YARA and have done some initial detections, well, let's expand our exploration into the YARA rule syntax and learn how we can write our own rules and also make sense of rules that we come across in the field. And so the syntax of a YARA rule is actually really easy to understand. And it's one of those things where it can just take minutes to understand, but months and years to master. And so our goal here is to learn how to get to that point and understand the fundamentals and best practices to lead us on a good path. And the best way to do this is to run through some real examples. And so under our YARA folder here, if we go into the samples directory, well, we're going to find this mimikatz.exe.meow file. And the reason for this meow extension is because, this is a malicious tool. We looked at Mimikatz before. It's not so much as malware as it is, a hacking tool to harvest credentials after an attacker has compromised a system. But still, as best practice, we don't want to be accidentally clicking on any executable files, especially in a Windows environment, and inadvertently running malware. And so changing the file type here, this could be anything, it doesn't have to be meow, but, I like cats. But this is a quick way for Windows to be like, hey, I don't know how to run a meow file, and so it's not going to. And so what we can do, just so we have some basic indicators to go off of, is just perform the most absolute basic static analysis that anyone can do. And so let's return to the strings command and run it against the compiled Mimikatz binary and see what readable text or characters we can pull back. And so I'm going to run strings against mimikatz.exe.meow, and I'm going to pipe this over to less, because we're going to get a long list of output. And so at first, we have this first line here. Remember, this is an executable, or that portable executable format. And so we can see this string of this program cannot be run in DOS mode. And now, this is definitely something we want to match for, right? We want to be sure that we have a condition in place that will match any executable files. But we've used that MZ header, or that magic byte, as a reliable way to see if we're dealing with an executable. It's not perfect, it's not foolproof, but it is one of those indicators that we can use. And there are a few ways to actually do this with YARA rules, and we'll go through a couple of ways. And so as we start scrolling down, we're getting a bunch of gibberish, which isn't really helpful to go off of, right? And if we really wanted to do some static malware analysis, we could run something like floss or, some other utilities to dig into the bytes and do, some more magic behind the scenes to give us more to work off of. But again, I'll keep saying it, this is not a malware analysis course, and I don't want to overstep. I just want to show you, how YARA rules can be read and created. And so what I'm going to do here is just press Q to quit. And let's run strings again, and this time work our way up. And so I'm just going to run strings on its own, and we're going to be brought down to the bottom here. And we're starting to get some more, readable characters, right? We can see some references to certifications or certification authorities or CAs. We can see references to Unizeto technologies. And so this might be the way in which the Mimikatz binary is signed. And so we can keep scrolling up, and oh, look at this. We have a URL. And so we can see within the string content of this executable, well, there's a URL to this blog.gentlekiwi.com website. And this is the blog site of the actual creator of the Mimikatz tool, or Benjamin Delpy. And we can see it even includes a /Mimikatz directory for us. And so this is awesome, right? At least in this example, we can use this as a string to match off of, right? And I'll make sure to point out, this is easily something that can be modified by the attacker, but it would require them to change the code and then recompile from source. And so remember, this is the pyramid of pain in action. If we create a detection to include this string, well, we can detect anyone trying to transfer over the pre-compiled Mimikatz executable onto a system or over the network. And, depending on the sophistication level of the attacker, it can cause them a bit of pain to have to figure out what's being detected and go back and modify the source code and recompile the binary. But I will also say there are many different ways to detect a Mimikatz executable, and many ways are much more rigid and robust than this example that we're writing here. And so you can just do a Google search for Mimikatz YARA rule, and you're going to find tons of examples that go much deeper into matching hex strings or byte sequences or looking at keys. And so again, this is just for a simple example to learn the syntax and not how to write the best all-encompassing rule. And so I'm just going to copy this value. And so we can now assume that we've already either performed basic static analysis like we just did, or remember, this isn't a malware analysis course, so we can assume that we have some sort of threat intelligence telling us about some unique strings inside this binary that we can look for in terms of writing a detection rule. And so let's create a rule to detect that URL string. And so what I'm going to do is back out of this directory and go into the rules directory. And from here, I'm going to run Sublime Text and create a new rule file called Mimikatz .yar. Now, YARA rules are really easy to write and understand, and they have a syntax that kind of resembles the C language. And when we're writing YARA rules, we basically just need to remember 3 main sections, and then the bulk of mastering YARA comes with writing conditions. But what we should do first is get the structure and the syntax ready. And to do that, we can head over to the documentation, and then go under Writing YARA Rules, and I'll have this link down below, as I always do. And so you can see that each rule in YARA starts with the rule keyword, followed by a rule identifier. And so basically, this is just going to be the name of our rule. And so let's go ahead and do that. So on our first line here, I'm just going to write rule, and the actual name of the rule can contain any alphanumeric characters and the underscore character, but the first character can't be a digit. And there are also some reserved keywords that we can't use in our rule name, which you can find here in the documentation. But as best practice, remember, the rule name is sometimes the only or the first piece of information that's going to be shown to a user, and so it's recommended to be as verbose as possible when we're writing rules. And so we should include information about the type of threat that we're chasing, and different tags that classify the threat, and even if possible, a short descriptive identifier or the context around the rule and its detection. We can separate these different values with an underscore. And I'll link a README down below from Florian Roth, who is the head of research at Nextron Systems and is a big name when it comes to sharing and writing YARA rules. And so if you start ingesting YARA rules, you're definitely going to come across his name many times. And Florian outlines some guidelines or best practices when it comes to naming YARA rules. And so just to get you a bit into the habit of being descriptive, well, we can call our rule here something like MAL for malware, with an underscore of Mimikatz, so the name of the malware, with an underscore, and we can provide the platform here, so Windows or Win, and then exe for executable, the file type, and then we can put a rough date, so in this case, August 24, but feel free to change this to, whatever you want. And from here, I'm going to hit a new line and open up a set of curly braces. And this is going to contain all the different structure and sections within our rule. And speaking of which, well, rules are generally going to be composed of 2 main sections, and that's going to be the strings definitions and the conditions. And the strings definitions are not required if the rule doesn't rely on any string matching, but that's, more or less uncommon. However, the condition section is always going to be required. And so the strings definition section is where the actual strings that will be part of the rule are defined. And each string is going to need a unique identifier, which we use with a $, which I'll show you in a second. But again, we can almost think of it like a variable that we can then include in our conditions. And again, we're kind of jumping ahead a bit, but as best practice, we should also include a meta section. And so remember how I said there are 3 main sections, but then I just said there are 2. Well, the first one here is something that's optional, but again, as best practice, we should always include a meta section. And the meta section in a YARA rule is used to include, well, metadata about the rule. And the reason why it's highly recommended to include one is, well, it provides that context and additional detail about the rule. And so we can have things like tags and author details, references, and descriptions. And if we look at any good YARA rules repository, like Florian Roth's here, which I'll have linked down below, well, we can see that all of these samples are going to contain a lot of metadata about the rule itself. And so we'll have things like a description, license information, the author. We're going to have references in the form of links. And so this could be news articles, or blogs, or threat intelligence research. We'll typically have a date field, sometimes a unique identifier, and also sometimes we might have hash values, right? And so maybe if our detection is related to a specific hash or a specific binary, we can include its hash here for reference. I don't see it in this one, but in some cases you might see a score field as well. Oh, you can see it here. And so it's supposed to be used to represent the rule severity, right? Like how critical the threat that it identifies is. And so let's write up our metadata for this rule. And so after we create our little, curly brackets here, we want to define our meta section with 2 tabs here. So I'm going to hit the tab key twice, and then I'm going to type in meta with a colon. And from here, if we just hit a new line, well, it's going to make sure that we're already auto-tabbed. And so again, this is why we want to use something like Sublime Text or a code editor to write our rules. And so for the description field, I'm just going to type in description, and then I'm going to set that to equal a string. And this string is going to include, our description. And so I'm just going to say that this rule detects the Mimikatz executable using a hard-coded URL string. All right. And so next we can identify the author. And in this case, I'm just going to call it TCM, but feel free to put your own name here because, you are the author of this rule. For the date, Well, you can just put today's date, whatever that is. We can also add the reference meta tag. And again, in this field here, we can provide links or URLs for any references that relate to the malware we're identifying or any threat intelligence reports that can support our rule. And so for example, I can just put example.com / malware 12. And so next, we can also include tags, right? And so tags can be useful to classify and group related rules together. And so you'll often see them defined. And so for example, we can just call this malware. We can identify the platform of Windows. And because this is Mimikatz, well, we can say it's dumping LSAS or something. I talked about the hash field as well, and so we can include one here. And what we can do is just head back to our terminal, and I can just run SHA-256-SUM onto our samples, mimikatz.exe.meow, and we can grab that SHA-256 hash of the Mimikatz executable. And just paste that in there for hash. We can put a unique ID as well. In this case, not really unique, 1, 2, 3, 4, 5. And we can also put a version, right? If we, want to have some version control on our rule, if we need to update it later on, right, we can just name this version 1.0. All right, so with our meta section out of the way, we can define the string section of our YARA rule. And again, the string section is going to be that, section to define the patterns or sequences of bytes that the rule is going to search for within files. And so to define this, I'm just going to create 2 new lines. So we just have, a line of space there. And then I will type in strings with a colon to specify the start of this section. And so to do this, remember, we need to have a unique identifier or a variable name for each string that we want to match. And it needs to start with that $. And so in our case, I can just call this URL. Because remember, we want to match that specific URL that we found from, the raw extracted strings during our very basic static analysis. And so I'm going to set the URL within quotes here to the value that we identified. And so that's going to be http://blog.gentlekiwi.com/mimikatz. And then optionally, we can also declare what type of string this is, right? And so we can just say something like ASCII to identify that this should be an ASCII string. Nice. And now remember earlier, I mentioned that we want to make sure that we're detecting executable files. And if you remember all the way back in the phishing and network analysis sections where we dealt with a lot of malware, well, we learned that the magic bytes or the file signature behind any executable or portable executable or that PE file is the MZ header, right? So the file is going to start with those bytes or those hexadecimal characters indicating MZ or MZ. I keep saying it differently. And to prove this, we can hop back over to our terminal and we can run something like hexdump on samples, mimikatz.exe.meow. And then what I can do is provide, again, that capital C there, and then pipe it over to the head command. And you can see this first line here, we have 4D5A. And if we look over, well, we have MZ or MZ. And apologies if I'm confusing you with MZ or MZ. What I really mean is MZ, I'm just Canadian and we say Z. But anyways, we can see this DOS header or that 4D5A translated over to the MZ. And so let's add this to our string declarations within our rule file so we can tell the YARA engine to also check that the file isn't executable once we start defining our conditions. And so I'll hop back over to Sublime Text here, and we can define another string. And so in this case, with the $, I'm just going to call it PE_signature. And I'm going to set that to MZ. But we could also use the hex value instead. And so what I can do here is just copy this line. What I'm going to do is put 2 slashes in front of it, and this will basically just comment out this line, and so it's not going to be read. And I'll just paste it in again, and this time edit the value. And so instead of quotation marks, to identify hexadecimal characters, we can use the curly braces. And so within this here, I'm just going to type in 4D5A. And I can even just put a comment here at the end to specify that this means MZ in hexadecimal. And so now in this example, we're happy with our strings and the different patterns that we're matching on. And so now we can move on to the condition section. And this is a very powerful section in our rule because it allows us to combine different logical operators, like the AND or NOT, and combine multiple string conditions. And we can also specify the location or the offset of these strings as well, which we're going to do here in a second. Or we can also use regular expressions or different qualifiers, or even built-in functions, or look at file properties like the file size. And so we can get very complex with our conditions here, And there's just no way that we can cover everything unless we turn this into a 10-hour YARA course, which may be a future consideration for the TCM Academy. Who knows? But let's keep things simple here for our first rule. And so for our condition, I'm just going to type in the condition section here with a colon. And now for our first condition, let's identify that the file needs to be an executable. And we can do that by specifying that the very beginning of our file, like the first position where those file headers or signatures are located, and make sure that it matches the 4D5A hex value that we identified under our PE variable or identifier here. And so to do that, what I can do under the condition is just put in the name of that identifier, and you can see we're already getting some helpful syntax cues. And I can select that this identifier should be located at the 0 position in the file, meaning the very start or the first byte. And so there we go. We are halfway done with our conditions. And so now what we can do is pass in the AND operator so we can finish off the remaining condition. And after this, I'm just going to hit a new line just to separate it out. And so again, this is the logical AND. And so it'll only detect the file if the first criteria or condition matches along with the second one that we're about to define. And for the second condition here, well, we can just simply include the URL identifier. And so this is just saying that, this URL that we identified earlier within this string has to be present somewhere, anywhere inside the file, and that it also must be a portable executable. But, YARA's condition is really powerful, right? We could change this instead of an AND to an or an AND not. But obviously for this example, we, don't want to do that. Let's leave it at AND. But we could, right? If we had multiple conditions, we can also throw them inside parentheses. Very similar to what we were doing with our snort rules, right? And so let's save out our rule here. I'm just going to hit Control S to save and head back to the terminal. And from here, let's test out a rule and see if we can detect the Mimikatz file. And so I'm going to run YARA with our Mimikatz rule here defined. So I'm just going to type in Mimi, what do we call it? Yeah, mimikatz.yar. And then to select our file path here, I'm going to back out over to samples and then provide the Mimikatz file. And look at that, we got a hit. And so let's print out the matching strings as well as their positions with that S argument. And we can see that we match 2 instances of that URL string. And so it looks like there was another location in the file where it also existed. And we match the portable executable based on its file header. And again, just for, verbosity's sake, let's also try this on the hello world.exe file. And we should not get a hit, and we don't. And so with our very basic first example here, we successfully identified and detected the Mimikatz binary. And we could go ahead and ingest this rule into our different security controls and appliances to say, hey, whenever you get a detection from this rule from a file going over the network or being downloaded or created on a host, well then fire off an alert or actively block it and delete it. And so that's how all of this starts to come together, right? And that's why YARA is so powerful from a threat intelligence and a threat hunting perspective, right? Because we can ingest rule files just like this and make sure that our detections are up to date and that we have powerful ways to weed out false positives to match what we need to and feed those alerts into our SIM. And remember, YARA is not an antivirus or an EDR tool on its own. It's not going to do anything to these files, like stop them or block them or quarantine them. It's just going to tell us, that binary output, true or false, is there a match or not? It's only when we integrate YARA into other controls that we can then do stuff with it. And so just to drill down the concepts even more, what I can do is just edit our rule file here. Well, let's change this to and not, and then we can save the rule. And so now if we think about this, it's going to match any portable executable file that does not contain this URL. And so we basically just reverse this one condition here, right? And so now, if I go back up and try to run, our YARA file against the Mimikatz executable, we should get nothing. Because that URL is in fact included. But if we run it against Hello World now, well, now we're matching it, right? Because it is a portable executable file. If I just run the tech S there, we can see again why it's matching. It's because of that magic file header. And so I will just change that back before I forget.